All right, so you need to know this one is greater than. And if you haven't memorized it already, please, again, like I said, keep working at it. This one is less than. The third one is the greater than or equal to. And the fourth one is less than or equal to. And sorry, the last one?
Not equal.
Good, not equal to sign. Not equal to. What sign up there is missing that you might think, wait, where is it? It should be there, right? What's that sign? The equal sign. Why is the equal sign not up here? It does not belong here. The equal sign is not here. It does not belong here, but why? Drew?
Because we're doing inequalities.
Yeah, we're talking about inequalities. So there are some that include an equal to component, but they're not just straightforward equal to. Okay, so you should know those there. Any questions on the signs? Any questions on those signs? I hope not. Okay, let's go to our first example. So we're technically on page 98, but I'm also looking at 99 because there's a lot going on there. Page 99, I'm going to look at number 1. This is the inequality they give me. Can anyone read this inequality? How do I read that so we get comfortable? So 5x, let's go with Phil.
5x minus 2 is less than negative 12.
Good. 5x minus 2 is less than negative 12. Okay, good. And then they give us what we call a replacement set. And they abbreviate that with an R. Okay, you could represent the replacement set with capital R. Then they give me these 5 numbers, negative 6, negative 4, negative 2, 0, and 2. Like, why would they do that? On this problem, you're not graphing anything. You're just trying to tell me which one of these numbers, or which numbers, or which one of the numbers would make this inequality a true inequality. That's what you're asking. Which one of those numbers will make that a true inequality? It's like, what do you do? Instead of the x, what are you going to replace it with? You're going to start with replacing it with negative 6. So all you're going to do is you're going to evaluate. Okay, is this a true statement? Is this a true inequality? What's 5 times negative 6? Negative 30. So negative 30 minus 2 is less than negative 12. Is that true or false?
True.
So I heard it from some. I'm not sure if others believe it.
True.
Okay, what's negative 30 minus 2?
-32.
Wait, negative 32 is less than negative 12?
Yes.
Yes. So this is where I'm going to start my answer. I'm going to start with another brace, and I'm going to put negative 6 in there. Out of the replacement set, out of these numbers, which numbers make this inequality true? The first number that makes it true is negative 6. What do you think I'm going to do next? I'm going to do the same thing, but instead of negative 6, I'm going to put in negative 4. What's 5 times negative 4? Negative 20 minus 2 is less than negative 12. Is that true or false? So what's negative 20 minus 2? Negative 22. Is negative 22 less than negative 12?
Yeah.
Yes, so that's a true statement. Negative 4 is also a part of the solution. Negative 4 works. In fact, guys, is there truth in this problem? Is there truth?
Yes.
What do you think? Is there truth to this problem? Like, is there things that make this problem true? Yeah, what 2 numbers make it true? Negative 6 and negative 4. Let's check the next number, which would be negative 2. All right, what's 5 times negative 2? Yes, negative 10 minus 2. Ooh, is negative 12 less than negative 12?
No.
Does negative 2 go in my solution set?
Yeah.
No, I do not put negative 2 because negative 12 is not less than negative 12. It's not true. Okay, what about 0? Would that work?
No.
Bummer. Really? Wait, it's 5 times 0? 0 minus 2?
-2.
Is negative 2 less than negative 12?
No.
What about 2? Do you guys know something? Do I have to try them all out? No. Once I find one that maybe doesn't work, you can kind of extrapolate and say, you know what? If negative 2 didn't work, I can kind of check 0. That doesn't work. So guess what? Does 2 work? No. So you can find patterns to help you to figure out which ones are going to work and which ones are not going to work. This set right here is called the solution set. This solution set includes all the numbers in the replacement set that make this inequality true. And it's only 2 numbers in this case. Yes, sir?
We always use that.
There's different replacement sets.
How will we know?
They'll give it to you. They give you the problem, and they give you the replacement set, and they ask you, all right, which one of these will fit into that? And you give it whichever ones they are. Okay, you guys kind of get that? You know what? This problem right here is basically you're checking your answer. You're checking to see, all right, if I got this as my answer, is it really true? That's all you're doing. It's a very straightforward lesson, hopefully not too hard. All right, here we go. B minus 1 is greater than 6. What's the replacement set? 0, 1, 2, 3. All right, it's very straightforward. So which one of those numbers work? That's your job to figure out. So what should I replace B with? 0. All right, 0 minus 1 is greater than 6. Is that true or false? That does not work. 1 minus 1 is greater than 6. Is that true or false? Oh, man. 2 minus 1 is greater than 6. 3 strikes, you're out. Okay, 3 minus 1 is greater than 6. Are there any other numbers in the replacement set to check? Nope. So here's my answer. Ready? It's going to have that brace. Would 0 fit in there? Should I put 0?
No.
Not 0. Nothing is in there. It's an empty set. So again, remember how I told you there's a difference between 0 and nothing? Well, sorry, it was 8th grade. There's a difference between 0 and nothing. 0 is neither neutral nor positive. Nothing is nothing. None of those. None of the above. So that's your answer. That's no solution or an empty set. Or like a cool superhero symbol. I don't know. Okay, so that's what you have. You guys get that? Pretty straightforward? Okay. Those aren't the only problems you're going to get today. It gets a little more complicated with the expression, but then look at my replacement set. That's really what does that mean? -3, -2, -1, 0, 1, 2, 3. So they don't have to write all the numbers in, but they are all included in the replacement set. You got to be kidding me. I got to check them all? Let's try it out. Let's check the first one. What do I put?
-9.
Sorry.
-3.
Yeah, -3 in there. Make sure I write this correctly. And you put -3 in for both A's because it's replacing the variable A. What's 3 times -3? -9. What's -9 minus 1? -10. All right, so is that less than, what's 2 times -3? -6 plus 1?
-5.
Is -10 less than -5? It is. So -3 works. Ooh, that's nice. What do you think I have to check next? -2. And I'll go a little bit slower on -2. All right, so I'm going to put -2 in here. -2 in here. What's 3 times -2? -6, and then -1. What's 2 times -2? -4 plus 1. Okay, what's -6 minus 1? -7. What's -4 plus 1? Ooh, is -7 less than -3?
Yes.
Oh, okay. So what's the second number? -2. Mr. A, am I going to have to do this for every number? You tell me.
Yes. Maybe. Yes. Every number.
Yeah.
Yes, ma'am?
Until you find one that doesn't work?
Yeah, there's usually going to be a little pattern here that you're going to start from the beginning, work your way up, and then once you hit a number that doesn't work, that usually tells you, hey, the rest of them don't work as well. You try out -1, and somebody's going to tell me what I get at the end. Something is less than something else. You tell me what it is. I don't know what it is. So we're trying -1 now, and you're doing it on your own, and hopefully we'll be able to verify it. So that's where you're checking. This is review of Chapter 1. Chapter 1. Didn't you have to multiply positives and negatives?
Yeah.
Didn't you have to add positives and negatives? You're doing this now all over the place. You're doing it 1, 2, 3, 4 times. You're doing that kind of problem. You're doing it 4 times for one number. Guess how many times you could have done it for this problem? Many, many times. So is it good to know what adding and subtracting of negative numbers is going to give you? Is that good to know? Do this. Multiplying, dividing. Yeah, you're going to need to know all that because that all applies to this problem. Okay, what did you get here when you simplify this left side? Anybody? -4. What about the right side? Is that true? So what other number should fit? -1. All right, what about 0? Does 0 work? Is -1 less than 1? Mm-hmm. 0 works. Does 1 work?
Yep.
Does 1 work? I'm going to put it down here. Does 2 work?
No.
Who said no?
Serious.
Thank you, Drew. Drew, why does 2 not work?
Because I worked it out.
Yeah, what'd you get?
I got 5 and 5.
Is 5 less than 5?
No.
No. Now, what do you think? Yeah, good. It's equal to. It's not less than. But would 3 work?
No.
No, because this is going to be a bigger number, and that's going to be a smaller number, so you're going to get this solution set. And just because I didn't have space, I didn't put it on one line, but that's how you can draw it. That's your answer. You guys get that? Some of them are going to, well, how many of you think that's long? It isn't that bad. Okay, listen to me carefully. Keep your books open real quick and open up your workbooks, the paperback book. Open that up to page 109. 109. You thought that was long?
No.
Oh, yes. No. I just want to explain some things. 109 in that workbook. All right, I'm not giving you your homework yet, even though I did show it off in last period. Sorry. Or not sorry, I guess. I don't know. Okay, on page 109, do you guys see 1 through 12? Okay, basically, they're just giving you 5 numbers. You have to check them all. Number 5 is the only tough one, but even that one's not that bad. They could have just written those out. Okay, that one's straightforward, but look at... Yes, sir?
Do we have to write out the problem, or can we just work it out?
So you work it out as many times as you need to tell me which ones work. So you don't have to check them all, but you do have to check the ones that you said are right.
Do we have to show the problem?
Yeah, like for example, I need to show at least this right here. I need to say 5 is less. So you know that was false. Because if you just put true or false, or you just put the numbers, I don't know. Did you just look at somebody? Did you just guess? Hopefully not.
So for number 5, so it go 20, 25, 30, 35. What do we do?
40, 45. Yeah, that's a great question. Actually, turn the page to 110. Let me show you one that you might not like very much if you didn't read it the right way. Number 13. Look at the numbers 0, 5, 10, 15, ... 50. Miss Trey, you got to be kidding me. You got to do 0, 5, 10, 15, 16, 17, 18, 19, 20, 21, 22, all the way to 50? No. You have to do 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. But let me give you a little bit of hope, because some of you are like, if you can figure out the pattern, once it stops somewhere, usually that means the other numbers don't work. Or they don't work at all until you hit a number, and then the rest of those work. But there are patterns, and you can use those patterns to help you out. Okay. Excuse me? No, one more problem. Back to your textbooks. One problem. Textbooks. Page 99. Everyone should be on page 99 of your textbooks. I better say it the right way. Textbooks. Okay. I want you guys to do number 3. Let's do number 3. Tell me which numbers work for number 3. Page 99 in your textbooks. Number 3, where it says try these at the very bottom. So, yeah, this one. Page 99.
Is it number 3? Okay.
Mm-hmm. And it should be 9x is greater than or equal to 27. Oh, in your textbooks.
9x is less than.
9x is less than or equal to 27.
Are we allowed to use parentheses in our integer without brackets?
No, parentheses, you're talking about an ordered pair or triple or no. So you use the braces. Mm-hmm.
How do we, when do we use the braces?
Whenever you're talking about sets.
Okay.
So see how we want a solution set?
Yeah.
Use those braces.
Okay.
Mm-hmm. And actually in Algebra 1, we use one brace on the left side and not on the right side. That's something different. And we'll get to that next year. Man, those symbols are
So for each one,
picky.
Say if it works for 4, do you have to write this problem out 4 times and put each number in?
If you're certain that the rest of them are going to work or they're not going to work, then you can be done with that. But hopefully you got it
We
right.
have to show our work. We have to write the same problem out.
Or you can erase it. You could just, like I did, you erase the number and work it out again.
Well, how would you know we actually did it?
I'll see a lot of erasing. Yeah, you could tell. You could see that, oh, they did this many times. You drilled a hole into the paper. I knew you did it multiple times. Please don't drill a hole into the paper. Thank you. All right. Who has a solution set? So you have these braces and you have these numbers in there. Okay. I'm going to ask each one of you 1, 2, 3, 4. 1, 2, 3, 4. Okay. Hudson, does -1 work?
Yes.
Okay, -1 is part of the solution set. Was it Drew? Is 1 in the solution set? Yes. Darius, is 3 in the solution set?
Yes.
Yes. Sam, is 5 in the solution set?
No.
No. Philip, is 7 in the solution set? No. Did you notice that 5 didn't work? Why would 7 certainly not work?
Because it's bigger.
It gets even bigger, so it didn't make it part of that solution any more than the other numbers. Okay, you get how to do it? Pretty straightforward. A nice, easy lesson to kind of get us started off. But don't worry, guys.
It gets harder.
That's my line. Okay. Your homework.
Can I?
2 to 16 even, pages 109, 110,